Okay, so hello everyone. So in this video, we're going to discuss the concept of the center of mass of a rod as well as the linear density. Okay, now in the previous video, diniscuss natin yung concept no ng center of mass. This time, i-extend natin siya sa context na meron tayong isang rod and hahanapin natin yung balancing point nun. Okay, to make the discussion more meaningful, we're going to be considering what we call a non-homogeneous rod. Okay? Ang ibig sabihin ng isang non-homogeneous rod is that yung density niya varies as we go to different parts of the rod. So, ibig sabihin, it's not as simple as finding the middle of the rod to get the balancing point. Okay? Now, before we proceed to getting the center of mass of a rod, i-discuss muna natin yung concept na tinatawag nating linear density. Now, yung density na alam natin before, so yung density na alam natin before, this is yung mass per unit volume. Now, meron tayong tinatawag na linear density. Note na dito, mass per unit volume, kapag linear density ang kinoconsider natin, ang difference nito is what we're doing is we're taking the ratio between the mass and the length of the object. So, mass per unit length ang measure or ang minimeasure natin for linear density. Kaya ang pinaka-common na unit of measure for linear density will be kilograms per meter. Okay, we're going to denote the density or the linear density as rho. So again, rho is equal to mass over length. So this would mean, by manipulating this equation, we have mass is equal to rho times the length. Now we're going to make use of this basis in order for us to get the mass of a rod. Okay, the mass of a rod, again, we can think of it as density times length. Now suppose yung density natin nga is denoted as rho of x. Let this be the density or the linear density. Yung mass natin is density times the length. But as I've said, yung density nito, magva-vary yan as we travel across the rod or as we go to different parts of the rod. So, hindi siya uniform. And we're going to make use of this formula. So, we have that the mass is equal to the definite integral from 0 to L ng rho of x dx. Okay, so a brief explanation kung bakit ganito yung formula natin for the mass of a rod. Okay, again, let me just write this or let me just specify that this is the mass of a rod. Okay, this one, it's clearly the density kasi yun yung define natin. Tapos, yung d of x, this gives you the measure from one or from the end point of the rod, yun yung denoted by 0, to any location along the rod. And then, we make the difference very, very small. Tapos, we take the mass and we sum it all up. Kaya ganyan yung formula natin for the mass of a rod. Okay? Now, since we want the center of mass of a rod, papasok rin dito yung tinatawag namin moment of mass of a rod. Okay? Now, same with the previous one, yung moment is the mass times the distance. No? So, if we consider that, moment, this is mass times distance. Yung moment of mass of a rod will be given by the definite integral from 0 to L ng x rho x dx. By the way, L here will mean the length of the rod. Okay, this one gives you the distance from the endpoint. Tapos, ito yung mass. Okay? Now, therefore, yung ating center of mass of a rod, it would still be given by the moment all over the mass. So, in terms of the integrals, it would be the definite integral from 0 to L ng x rho x dx all over the definite integral from 0 to L ng rho x dx. Okay, so we're going to be making use of this formula to solve a few examples. Okay, let's solve this problem here. The length of a rod is 4 meters, and the linear density is given by rho of x equal to 3/4 x plus 2 kilograms per meter from any point x from one end. So find the center of mass of the rod. Okay, from the problem, we have that the length is 4 and the linear density is given as 3/4 x plus 2. So dito pa lang nakikita nyo no, that the density is not uniform. Kasi if we switch or if we change the value of x, maiiba yung density niya at that particular x value. Okay, so the center of mass of a rod is again given by the moment of mass all over the mass, which in terms of integrals is the definite integral from 0 to L ng x rho x dx all over the definite integral from 0 to L ng rho of x dx. So it's really just an application of yung mga pinag-aralan natin of first 2 quarters. Okay, so all we have to do is substitute the values. So we have definite integral from 0 to 4. So this is the length of the rod of x times 3/4 x plus 2 dx all over the definite integral from 0 to 4 ng 3/4 x plus 2 dx. Now, solving this, adjust ko na lang dito sa gitna. Solving this will give us 3/4 x squared plus 2x dx all over definite integral from 0 to 4 ng 3/4 x plus 2 dx. Getting the antiderivative and performing FTC2, this will give us 1/4 x cubed plus x squared evaluated from 0 to 4 all over 3/8 x squared plus 2x from 0 to 4. All we have to do is evaluate both the numerator and denominator at x equals 4 kasi at x equals 0, magzi-0 naman itong dalawa. Okay, so at x equals 4, the first or the numerator will become 1/4 times 64 plus 16 all over 3/8 times 16 plus 8. Now simplifying, so this will be 16, this will be 2. So we have 32 all over 14 or 16 over 7. Okay, so what does this mean? Now, again, we're looking for the center of the mass. So, ibig sabihin, yung unit of measure dito will be meters kasi yung length na ginamit na sa atin is 4 meters. Okay, so the center of mass is 16 over 7 meters from the end with smaller linear density. Okay, paano natin nasabing smaller linear density? Note na yung linear density na given sa atin was rho of x equal to 3/4 x plus 2. X here would mean yung distance from the endpoint, no? So, ibig sabihin, at x equals 0, 2 yung linear density niya. So, at x equals 1, lalaki yung linear density and so on. So, ibig sabihin, as we travel farther from the endpoint, lumalaki yung linear density natin. Okay, so 16 over 7 meters from the end with smaller linear density. Okay, next example. So for the next example, the total mass of a rod 2 meters long is 18 kilograms. If the linear density varies directly as the cube of the distance of the point from one end, find the linear density at the midpoint of the rod. Sabi sa given, we have that the rod is 2 meters long. So, L natin ay 2 meters. And then, yung mass daw ay 18 kilograms. We want to find the linear density at the midpoint of the rod. So, technically, what we're after is if rho of x gives us the linear density, we want to find the density at the midpoint of the rod. Pero given tayo na yung length ng rod ay 2 meters. So yung midpoint niya will be the same as rho of 1. So this is what we want to find. So how do we make use of what is given? We're given the length and we're given the mass. Now the mass, we know that the mass is equal to the definite integral from 0 to L ng rho of x dx. So in turn, we can say that 18 is equal to the definite integral from 0 to 2 ng rho of x dx. Kaso, hindi pa natin alam yung actual value ng linear density. Pero, given tayo that the linear density varies directly as the cube of the distance of the point from one end. Okay? So, if we recall our direct proportion, we can say that rho of x is equal to kx cubed, where k is a real number. So, hahanapin natin yung actual na value ng k using this information that the mass is equal to 18. So, i-substitute natin ito. So, 18 is equal to the definite integral from 0 to 2 ng kx cubed dx. Applying FTC2. So, this would mean 18 is equal to k over 4 x cubed, x to the 4th na. X to the 4th when we evaluate this from 0 to 2. Now, at x equals 0, mag-0 lang ito. So, all we have to do is evaluate at x equals 2 and solve for k. So, at x equals 2, we have 18 equals k over 4 times 16. Simplify. So, we have 4. So, 18 equals 4k or k equals 9/2. Now, we have the value of k. Substitute na natin yan sa ating linear density. So linear density is equal to 9 halves x cubed. And then recall, we wanted to find the density at the midpoint of the rod, or that is the same as rho of 1. So rho of 1, this is 9 halves times 1 cube, or 9 halves. And then yung unit of measure natin na ginamit ay kilograms per meter. So the linear density at the midpoint of the rod is 9 halves kilograms per meter. So this is just a short video on the center of mass of a rod as well as the linear density.